Welcome back. So now we will be working on section 8.1 of from web work. All right, confidence interval mu sigma known. So sigma is known in this particular section. All right, match the confidence in level with the confidence interval. So you have a certain number here. If you look at the formula for error, maximal error, it is z sub c sigma over square root n. So that's the error, maximal error. So that quantity is z sub c because the rest is sigma over square root n. So this is z sub c, this is z sub c, this is z sub c. You want to match these with the confidence levels. So we look at our table. If I can find it here, there you go. Okay, so this is the table and here is the confidence intervals. All right, so 2.575, that's approximately here. 99% is a confidence level, 0.99 or 99, so that's A. This is A. 1.96, that's here, that's 95%, 0.95, 95%, so that's a B. 1.645 is 90%. C. Next problem. Here we are told for 30 randomly selected Rolling Stones concerts, the mean gross earnings is $2.31 million. Assuming a population standard deviation gross in earnings of $0.45 million, obtain a 99% confidence interval for the mean gross earnings of all Rolling Stone concerts in millions. So you want to build a confidence interval. Let's go back to the theory here. So what do we know? We want to build confidence interval for mean when sigma is known. X bar is the sample mean of simple random sample. ZC is a critical value. Then E is the error, maximal error allowed, given by this formula. X bar minus E, X bar plus E is your interval, confidence interval. All right. So I have written this information here. N is 30 because we have 30 randomly selected concerts. N is 30. The mean for these 30, so in other words, this is the sample mean, that's 2.31. So sample mean is denoted by X bar. Assuming a population standard deviation, so the population standard deviation is denoted by sigma, and that's known to be 0.45. All right, we are told confidence level of 99%. All right, so you want the interval. So this is the interval you're looking for, and this is the maximal error you want to compute, and you need to find the, for this formula you need a ZC. ZC is given for this C. All right, so let's look for the critical value for 99% confidence level. 99% confidence level, that's the critical value, 2.58. Okay, now mind you, if you actually look using the table, it would come to 2.75. All right, so you might want to first try with this. If this doesn't work, try 2.575. Now this formula tells me I have a fraction. What goes upstairs? 2.58 times sigma 0.45 over square root n, which is 30. All right, we need to find this value. So I will use a calculator, or I don't, well, yeah. I may not, I don't have to use a calculator. I prefer using WebWork calculator because this will approximate as much as it needs to. All right, so whatever that value be, I'm going to subtract from x bar. So 2.31 minus whatever this value be, we are going to subtract, and then the right hand point is 2.31 plus the error. All right, so this is the interval. So let's write that down here carefully. 2.31 minus, so this expression is a fraction, so I'll write parentheses over parentheses. Who goes downstairs? Square root 30, SQRT, parentheses 30, close parentheses. What goes upstairs? 2.58 times is star 0.45. Okay, so that's the numerator, that's the left hand point of your interval. I will copy and I'll paste here. So make sure your parentheses are all okay, and the right hand side, it's the essentially the same expression, except you are going to add. Okay, so remember to add. Which of the following is correct interpretation? That's A in my case. We can be 99% confident that the mean gross earnings of all Rolling Stone concerts lies in. So we can be 99% confident. It is not the same as 99% chance. That's not the case. This is a confidence interval, so you can be confident. Now, this sounds very similar, but notice the difference. Of all Rolling Stones, so of all the concerts, you're looking for the mean gross, as opposed to for this sample, you're not looking for mean of this sample. All right. Okay, next problem. So notice it helps to keep the expression in rather, because look how much it kind of approximate. Okay, next problem. Starting salaries of 70 college graduates. So the theory is the same. I have sample size of 70 who have taken a statistics course. There is a mean, so this mean is for the sample. Therefore, it is x bar is 44,328. Sigma, that is the distribution of this population is approximately normal and standard deviation. So we are being told the standard deviation is for the population. So that's a sigma 10,661. Use a 99% confidence level, that is C is 99%. Do not use commas nor dollar signs in your answer. You want to find margin of error. Okay, so this is the maximal margin of error given here. So how do I find ZC? I again refer to the chart here. So for 99%, ZC is 2.58. All right, and then the margin of error is ZC, it's a fraction, sorry, 2.58 times the sigma 10661 over square root 70. So that's the setup for me. So that's my margin of error. So I will write it. I will not use a calculator. I'll simply write the expression here. Parenthesis over parenthesis. Denominator consists of SQRT 70. All right. And don't forget to close the open parenthesis. And numerator consists of 2.58 times is a star 10661. That's the margin of error. So the confidence interval is, I'll copy that information. I'll copy the margin of error. From X bar, take away margin of error. So X bar is 44328. So left hand point, take away margin of error that I copied. Right hand point 44328. Add, so that's X bar 44328. And now I'm going to add whatever I copied from there. Okay, that's it. So this completes Stat 8.1. Next videos will cover section 8.2. Until then, bye.